All right, so coming back to our ellipses here. So in graphing form, set up very similar to what we saw before, the major difference being in that our equation is now solved for y. Now those should both have squares on them. So once we get into graphing ellipses, which should happen Tuesday, I believe, you're going to be asked to use these two equations to graph. Now, I'm not going to spend a ton of time on it now just because we don't really have the time to waste. But those are our two major equations for us to use. Again, the difference between a circle and an ellipse is that the circle was cut parallel to the base of our cone. Here, it would be cut on an angle so that we end up with kind of this oval shape to it. Moving on to the back side of our page, we'll actually start with hyperbolas before we move on to parabolas, because that's where we're going to spend the most of our time. Now, hyperbolas, like we said, were cut this way. So you end up with a U shape at the top and a U shape at the bottom of our cone. We have those standard and graphing form equations here. We're going to focus just on the standard form equation for this. I'm not going to spend a ton of time on hyperbolas because these are considered an advanced Algebra 2 skill. They are not something you're going to be expected to do a ton of. If you want to use them for your project, they might be kind of handy. But this will be your setup. Now you may be thinking, wait, that looks exactly like the ellipse equation. There's no difference between this and the ellipse equation. But if you take a moment and you go back, maybe you see it. What's the difference? Hopefully what you're noticing is that this one has a minus sign in the middle. That is the only difference between an ellipse equation and a hyperbola equation. It's the fact that in order to make a hyperbola, you have to subtract our two pieces. That's what causes it to have those two pieces going out in either direction rather than towards each other like they do for the ellipse. So again, we're not going to spend a huge amount of time on these, but they might become useful as part of your project. Finally, we're moving on to parabolas. Now you might be thinking that we have done all we could possibly do with parabolas and there's absolutely nothing else for us to learn about them. But you'd be wrong. So in a parabola, we're cutting our cone kind of like this to make our U shape. Now we're used to vertical parabolas where it's y equals our a value x minus h plus k. But wait a minute, you didn't write a, you wrote 1 over 4p, right? In parabolas, for this unit, we're actually going to change how we think about an a value, that vertical stretch and shrink. 1 over 4p is the same thing as a. We're just using 1 over 4p because it helps us talk about the change or the delta from our vertex to what we call a focus. Now, part of what you're going to have to do for this chapter, or at least to start off today, is you're going to have to look up some important terms. We're going to use something called the focus. We're going to use something called a directrix. And we're going to use something called a latus rectum. Each piece is super important in terms of a parabola, and they're going to come from our information here. Now, a still behaves the same way. It's just, for this chapter, we're going to reference it as 1 over 4p. It's still stretch or shrink, it's just written a little different way. H still tells us whether the graph moves left or right. K still tells us whether the graph moves up or down. But we're not just talking about vertical parabolas anymore. We're also going to have a horizontal parabola, meaning rather than having our parabola sit upright like this or like this, we can now have parabolas that go like this or like this. And there's really only one change, well, two changes in the equation. Looks like this. Notice the major changes here. First of all, our x's and our y's flipped places. That's on purpose. So x is over here and y is over here. And then h and k end up flipping spaces. Otherwise, everything behaves the same way. H and k still tells you the vertex. They just show up a little differently in the equation. A/1/4p still tells you vertical stretch or shrink. The only difference is whether the parabola is sitting up and down or side to side. What you're going to have to do is use these three pieces of information, which you're going to look up on your own, to create parabolas. So if I were to give you an example problem that we'll talk about a little bit later, it'd be something like, I tell you the focus is at 5, 6, and the directrix is at y equals 1, and then ask you to write the equation of the parabola. Or maybe I give you the focus and I give you the vertex and I ask you to write the equation. Focus and directrix are just some new pieces of what we're going to talk about in this chapter. So we'll reference those a little bit more when we see each other on Friday. But your job right now, once you're done watching this video, is to go and define these three terms, because you will need them for this chapter. Then, once you move into the next piece, you'll be able to use those three pieces of information.